Okay, so this is the key to section 10.7 part A. And again, you're simplifying radicals just like in the previous worksheet that you did, 11.0 part A. Except this time you're going to have square roots of negative numbers. So um, hopefully you remember about the imaginary unit for those. Okay, so number one, you have the square root of 48. All right, now remember the perfect squares we discussed. So the square root of 48, a perfect square that goes into 48 is 4. But the question is that the largest? So if you can't figure out what the largest is right away, and you see that 4 goes into 48, then use 4 for right now. Let's think about that. So 4 times 12. All right, now right away you know that 12, you can eventually, the square root of 12, you would be able to eventually simplify because 4 goes into 12 as well. So 12 will be 4 times 3. And so now look at this. So multiply these perfect squares. 4 times 4 is 16, and that is your largest perfect square. So use 16. So it'll be 16 times 3. All right. And so then you get the square root of 16 times the square root of 3, which is 4 square root of 3. So that's number 48. Now, if you had not determined that 16 was the largest and you want to go ahead and use 4, that's fine. The issue would have had a lot of steps. Well, not that many, but you would have had a few more. So you have the square root of 48. You could have said 4. So it'll be 4 times 12. And so this becomes the square root of 4 times the square root of 12. That's 2 square root of 12. And you could have gone ahead and rewritten 12 as also 4 times 3. It's no big deal. In other words, you could have said this. You could have said the square root of 4 times, and the 12 is 4 times 3, and then said square root of 4, square root of 4, square root of 3, because the square root of products is the product of those individual square roots. And so you get 2 times 2 times square root of 3, which is 4. 2 times 2 is 4, square root of 3. See, that's another way. And then some people, though, they prefer to do it one step at a time. And so you would get 2 square root of 4 times 3. So that's 2 square root of 4, square root of 3. So that's 2 times 2, square root of 4 is 2, square root of 3. So you get 4 square root of 3. So either one of these methods is okay. Just remember, though, you always want to try and use the largest because it saves yourself a lot of time, and if you have too many of these steps, you could have easily messed up somewhere. All right, number two. Well, assuming that this is correct, let's think about this one. Well, this is correct, but the square root of negative 48. So this is the square root of a positive 48. This is the square root of a negative 48. So let's think about the square root of a negative 48. We know that the square root of negative 48 can be written as the square root of a negative 1 times 48. And we know that I can write the square root of a product as the product of the individual square roots. And we also know that the square root of a negative 1 is the imaginary unit I. So that's I square root of 48. And based on what we discussed a while ago, we know what the square root of 48 is. That's 4 square root of 3. So that's 4 square root of 3. But let me discuss how to write this. So there's nothing wrong with writing it as I 4 square root of 3, but the preference is to sometimes put the imaginary unit I between the whole number part of the radical and the square root part of the radical. So in other words, write it as 4I square root of 3. All right, so that's a perfect part. Now some people will write it like this. It does not matter. 4 square root of 3I. There's nothing wrong with that either, except be careful, because if you extend this the square root symbol too far, it kind of sometimes seems like that I is underneath, and it's not supposed to be. So it's supposed to be outside of that radical. So be careful how you write it. But I'm going to go ahead and write it as 4I square root of 3. All right, number 3, you have the square root of a negative 23. So again, square root of negative 3. So again, that's the square root of a negative 1 times 23. So that's the square root of a negative 1 times the square root of 23. So that's I square root of 23. And I can't simplify the square root of 23. Besides 1, there's no other perfect square that goes into 23. So you get I square root of 23. Number 4, you have negative square root of a negative 25. So let's think of this as the opposite of the square root of a negative 25. This number here, let's think of this as opposite. So the opposite of the square root of a negative 25. Well, I know that that's going to be the opposite of the square root of a negative 1 times 25. So that's negative square root, the opposite of the opposite of the square root of a negative 1 times the square root of 25. So that's negative, and then that's the imaginary unit I, and then that's times 5. Now, notice that here the radical was still in the answer, so you were taking the square root of 23, this was square root of 3. Here the radical is no longer there because the radicand 25 was a perfect square. But this is how we write it. So when you only have the whole number part, then put the imaginary unit I behind it, just like we did this. So right here. So we took the whole number part of the radical and we put it in front of the I. So the same thing here. So it'll be negative 5I. So that's how we prefer to write it. Number 4 is negative 5I. Okay, number 5, you have the square root of a negative 72. Square root of a negative 72. So that's going to be the square root of a negative 1 times the square root of 72. So that's I square root of 72. So imaginary unit I. Now let's talk about 72. 36 is a perfect square, is the largest perfect square that goes into 72. So you get I square root of 36 times 2. And you could skip some of these steps. You could, right away you could have seen, well, since that's the square root of a negative number, I know I'm going to have an I, so you can automatically put an I there. So you can skip some of these steps. But I'm just doing it step by step. So that's going to be I square root of 36 square root of 2. So that's I times 6 square root of 2. And let's rewrite it the way we prefer to write it. So there's going to be 6I square root of 2. That's number 5, 6I square root of 2. Okay, number 6, you have negative square root of a negative 12. So the opposite of the square root of a negative 12. So I'm going to rewrite this as the opposite of the square root of a negative 1 times 12. So that's the opposite of the square root of a negative 1 times the square root of 12. And 12 I can simplify. There's 4 is the largest perfect square that goes into 12. So I get the opposite, and this is I. Let's write this as 4 times 3. So I get negative I square root of 4 times the square root of 3. So that's negative I times 2 square root of 3. And so I'm going to rewrite this as negative 2I square root of 3. Right, so that's number 6. So negative 2I square root of 3. All right, number 7, you have 2 times the square root of 25. And notice that 25 is a perfect square, so right away that's going to be 2 times 5, which is 10. So number 7 is 10. Number 8, you have 4 times the square root of a negative 36. So 4 times the square root of a negative 36. That's 4 times the square root of a negative 1 times 36. So that's 4 times the square root of a negative 1 times the square root of 36. So simplifying this, the square root of a negative 1, we know that's the imaginary unit I. We know that the square root of 36 is a perfect square. So the square root of 36 is 6. And we also know that 4 times 6 is 24. So we get 24I. So number 8 is 24I. All right, number 9, you have the 5 times the square root of a negative 32. 5 times the square root of a negative 32. So again, step by step, I'm going to say 5 times the square root of a negative 1 times 32. So that's 5 times the square root of a negative 1 times the square root of 32. 16 is a perfect square that goes into 32, so keep that in mind. So that's 5. The square root of a negative 1 is I. I'm going to write this as the square root of 16 times 2. So that's going to be 5 times I times the square root of 16 times the square root of 2. Where 16 is 4, so that's 5 times I. And you can skip some of these steps. Times 4 square root of 2, and so 5 times 4 is 20. So I get 20I square root of 2. So that's the answer for number 9. So 20I square root of 2. All right, number 10, you have number 10, you have negative 2 square root of a negative 49. Again, you can some of these steps. Some of you can see right away that the square root of a negative 49 is 7i. But if you need to write in the steps, you can. So that's negative 2 times the square root of a negative 1 times 49. So that's negative 2 times the square root of a negative 1 times the square root of 49. So that's negative 2 times I. Square root of negative 1 is I. And then square root of 49 is 7. So this negative 2 times this 7 is a negative 14. So I get a negative 14i. So that's number 10. So number 10 is a negative 14i. All right, number 11, you have 3 times the square root of a negative 64. And so that's going to be 3 times this, oops, oh, that's fine, I could have written like that. So it's 3 times the square root of a negative 1 times 64. So that's 3 times the square root of a negative 1 times the square root of 64, like this. The square root of a negative 1 we know is I, so that's 3i. Square root of 64, 64 is a perfect square. Square root of 64 is 8. So 3 times 8 is 24. So I got 24i. So number 11, the answer is 24i. Number 12, you have 5 times the square root of a negative 12. So it becomes 5 times the square root of a negative 1 times 12. So that's 5. Square root of a negative 1 times the square root of 12. And 12 we can rewrite as 4 times 3. And so I get 5. Square root of a negative 1 is I. So I can write this as square root of 4 times square root of 3. So I get 5 times I times 2. Square root of 4 is 2 times square root of 3. 5 times 2 is 10. So I get 10i square root of 3. And again, you can skip some of these steps. So 10i square root of 3. Number 13, you have negative 7 square root of 8. Negative 7 square root of 8. So notice that I'm taking the square root of a positive number, so I'm not going to have that imaginary unit. So it's not going to be an imaginary number. Alright, so I get negative 7, and then the 8's the perfect square that goes into 8 is 4. So I get 4 times 2. So I get negative 7 times the square root of 4 times the square root of 2. So I get negative 7 times the square root of 4 is 2 times the square root of 2. So I get negative 14 square root of 2. So 13 is negative 14 square root of 2. And then finally, notice that the only difference between these two is that the radicand here was positive, the radicand here is negative. So number 14, you have negative 7 square root of a negative 8. So that would be negative 7 times the square root of a negative 1 times 8. So that's negative 7 times the square root of a negative 1 times the square root of 8. So that's negative 7 times, this is I. The square root of 8 we found to be, now be really careful, so I'm covering some things up here. Square root of 8, remember, is this part here. So I'm covering up all the 7s. So that's 4, square root of 4 times 2, square root of 2. So that's 2 square root of 2. So square root of 8 is 2 square root of 2. And so negative 7 times 2 is negative 14 I square root of 2. So the only difference between these two, notice that this one did not have an I in it, this one did, only because of that square root of a negative number. Alright, so number 14 is negative 14i square root of 2. Okay, so that is going to be the key to worksheet 10.7, part A.